So good day everyone, I am Jaey Trecia of Ellorimo and we are the group 3, which topics are all about the non-Euclidean geometries, and my assigned topic to be discussed is all about the Euclid's fifth postulate. So in mathematics, non-Euclidean geometry consists of two geometries based on axioms, closely related to those that specify Euclidean geometry. So as Euclidean geometry lies at the intersection of metric geometry and affine geometry, non-Euclidean geometry arises by either replacing the parallel postulate with an alternative or relaxing the metric requirements. So what is a postulate? So postulate is to suggest a theory, idea, as a basic principle from which a further idea is formed or developed, or either an idea that is suggested or accepted as the basic principle before a further is formed or developed from it. So here are the Euclid's 5 postulates. So first postulate is a straight line may be drawn from any one point to any other. So note that this postulate tells us that at least one straight line passes through two distinct points, but it does not say that there cannot be more than one such line. However, in his work, or Euclid's work, Euclid has frequently assumed without mentioning that there is a unique line joining two distinct points. Specifically, this postulate simply says that if you have any two points, such as the point A and B, say then you can always connect them with a straight line. So the second postulate is a terminated line can be produced indefinitely. So this postulate we can call a line segment nowadays is what Euclid's called a terminated line. So according to the present day terms, the second postulate says that a line segment can be extended on either side to form a line. So it tells us that we can always make a line segment longer, which means that we never run out of space and that a space is infinite. So the third postulate is a circle can be drawn with any center and any radius. So this postulate allows for the existence of circles or any circles of any size and center. So say the center has a point of A and the radius of AB. We do know that a circle has a diameter and the half of the diameter is the radius. So like say the end point of the diameter would be B and the point of the center is A, and therefore the radius is A and B, or line AB, or the radius AB. So the fourth postulate is all right angles are equal to one another. So it just say that whenever we create a right angle by erecting perpendiculars, the angles so created are always the same. So postulates 1 and 3 set up the ruler and compass framework that was a standard for geometric constructions until the middle of the 19th century. So they may be said to be based on man's practical experience. So the second postulate gives an expression to a commonly held belief that straight lines may not terminate and that the space is unbounded. So by the definition, an angle is right if it equals its adjacent and angle. So thus the fourth postulate asserts homogeneity of the plane. In whatever direction and through whatever point two perpendicular lines are drawn, the angle they form is one and the same and is called right. So we may think of the fourth postulate as having been justified by the everyday experience acquired by man in the finite, which inhabited portion of the universe, which is our world, and extrapolated to that part of the world whose existence and we sense and believe in. So here is the fifth postulate of Euclid. So if a straight line falling in two straight lines makes the interior angles on the same side of it taken together less than two right angles, then the two straight lines, if reduced indefinitely, meet on that side on which the sum angles is less than two right angles. So in this example, we show that it entails the fifth postulates. So it has the two parallel lines and one line is falling intersecting the two parallel lines. So here, for example, the line PQ in the figure, which PQ, the line colored in yellow, falls on lines AB, which is the first parallel line, and CD, which is the second parallel line. so such that the sum of the interior angles 1 and 2 is less than 180 degree on the left side of PQ. So therefore, the lines 1AB and CB will eventually intersect on the left side of PQ. We do note that the measurement or the angle of a line is 180 degree. So, a brief look at the 5 postulates brings to our notice that postulate 5 is far more complex than any other postulate. So, on the other hand, postulates 1 through 4 are so simple and obvious that these are taken as self-evident truths. So, elaborateness of the 5 postulates stand in a stark contrast to the simplicity of the first 4. So, Euclid himself probably had mixed feelings about it, as he did not make use of it until proposition. So the postulate looks more like another proposition than a basic truth. So here's, for example, a proposition claims that if angles A and B sum up to 2 right angles, then the lines L sub 1 and L sub 2 are parallel. So the phi postulate are also known as the parallel postulate. So, this postulate does not specifically talk about parallel lines. It is only a postulate related to parallelism. So, Euclid gave the definition of parallel lines in his book, which just before the 5 postulates. So, the postulate was long considered to be obvious or inevitable, but proofs were elusive. Eventually, it was discovered that inverting the postulate gave valid, albeit different geometries. So a geometry where the parallel postulate does not hold is known as a non-Euclidean geometry, and geometry that is independent of Euclid's fifth postulate only assumes that the modern equivalent of the first 4 postulate is known as the absolute geometry, or sometimes the neutral geometry. So now let us focus on the equivalent version of Euclid's fifth postulates given by John Playfair as per him. So in the given figure, or in the given diagram, the sum of angle 1 and angle 2 is less than 180 degrees. So lines N and M will meet on the side of angle 1 and angle 2. So in a plane, given a line and a point not on it, at most one line parallel to the given line can be drawn through the point. So in simple words, the above statement or the statement can be written as for every line L and for every point P not lying on L, there exists a unique line M passing through P and parallel to L. So that statement is given in this figure. So consider line L and a point P not lying on L. Now we know that an infinite number of lines can pass through a given point, thus infinite lines can pass through a point P. But are all the lines parallel to line L, or are some of them parallel to line L, or are none of them parallel to line L? So according to Playfair, there is only line passing through P which will be parallel to line L. So if we draw any line passing through point P, say line S, if you draw a transversal cutting lines S and L and passing through point P, we can see that on one of the sides, the sum of co-interior angles will be less than 180 degree. Thus, both the lines will meet in that direction. So there is only one possibility of line M, in which the sum of the co-interior angles of exactly 180 degree on both sides. Hence, in this case, both lines will never meet. So thus we can observe that this action by itself is not inevitably or logically equivalent to the Euclidean parallel postulate, as there are geometries under which one is true, so another is not. So still, each of these can be used to prove the other in the presence of the remaining axioms which give Euclidean geometry. So therefore, they are said to be equivalent in terms of absolute geometry. So that's the end of my presentation. Hope every one of us learned, and thank you and God bless.